Hello, everyone, and welcome to today's webinar hosted by the North American Sustainable Refrigeration Council, Natural Refrigerants and Supermarkets, the Winning Climate Solution. We are actually launching this webinar on World Refrigeration Day. So if you're not watching on this day, this was June 26th of 2020. But the information contained in this webinar is timeless and can be watched on demand at any time. So today we'll focus on why climate experts have named refrigerants as both the fastest growing greenhouse gas and #1 climate solution, focus on the environmental impact of refrigerants that are commonly used in supermarkets, and the transition to climate-friendly natural refrigerant solutions. We'll talk about the opportunities, the barriers to widespread adoption in the supermarket sector within the US specifically, and how NASRC is driving scalable solutions together with the support of our members in the refrigeration industry. My name is Danielle Wright, and I'm the Executive Director of the North American Sustainable Refrigeration Council, or NASRC. So first, a little bit about the NASRC. We are a 501c3 nonprofit organization. Our mission is to remove the barriers to the adoption of natural refrigerants in order to create a more sustainable future for supermarket refrigeration. The unique thing about our organization is we do this collaboratively with the help of the entire supermarket industry, over 130 members representing 24,000 supermarket locations, including a lot of supermarket retailers that you'll be familiar with, as well as equipment manufacturers, service contractors, consultants, engineering and design firms, and even utilities that participate in the refrigeration industry. So first question here is, if you're not familiar with HFCs, what are they? Hydrofluorocarbons, or HFCs as they're commonly known, are synthetic man-made chemicals that are typically used in air conditioning and refrigeration. HFCs are considered super climate pollutants. They have a very high global warming potential, with thousands of times more heat trapping power than CO2, which is a widely recognized greenhouse gas and also a natural refrigerant. I'll get into that a little bit later. They've also been identified as a short-lived climate pollutant because of their disproportionate impact on global warming in the near term. They are also the fastest growing source of greenhouse gases globally, and this has a lot to do with the global demand increasing for cooling in countries like China and India. And so we call it the #1 climate solution because it was identified by an expert publication called Project Drawdown that focuses on a comprehensive plan to reverse the impacts of global warming. And it is thought by scientists and experts that mitigating the impacts of refrigerants can help us avoid up to ½ degree of warming by the end of the century. And it's, what we refer to it as it's the most impactful and cost-effective climate solution that most people have never heard of. And if you look at Project Drawdown, you can compare some of the more commonly recognized carbon reduction methods, wind turbines and electric cars, and you can see that pound for pound refrigerants have a higher reduction potential for a fraction of the estimated cost. So this is why they're considered such an important climate solution. And why is it that we focus on grocery stores? If we take a look at the pie charts here down at the bottom, we can see that the refrigeration, air conditioning, and heat pump sector represents the largest or vast majority really of HFC use of all sectors. If we break that down a little bit further and look at just that refrigeration and air conditioning sector, you can see here that AC actually, or air conditioning, represents still the majority of HFC use. When we break down refrigeration a little bit further, you can see that commercial refrigeration, or otherwise known as grocery stores, represents the highest use there. But really what I'm interested in is for us to get to the pie chart on the right-hand side here, which shows, of the HFC use, where is that use going? And here you can see the difference between the filling up of new equipment and topping off of leaks. And that's really that 60% is where we're going to see grocery stores come into play here, because when we look at grocery store systems, we're going to find that these are large, complex, inherently leaky systems. And that by comparison, what we would refer to as a self-contained, or really this is the same type of refrigeration system you'll find within an AC unit that's providing that same cooling, extremely low leak rates, and a relatively small amount of refrigerant used. So when we compare that to what was known as a remote system that exists in the majority of grocery stores and supermarkets, here we're looking at a system that's interconnected by miles and miles of piping that is unseen to the customer eye. You walk into your grocery store and see a lineup of refrigerated products, beer, dairy, produce, but underneath it all is a very complex system of interconnected piping to keep that system cool and running. And that is the system that is inherently leaky. And we estimate the estimates based on the EPA Green Chill program is that these systems leak about 25% on average on an annual basis. And we're talking about thousands of pounds of refrigerant. So when we add up the impact of what we consider that to be a direct greenhouse gas emissions associated purely with the leak rates that are coming out of these systems. So here in the example on the left, we're seeing a typical system, 3,500 pounds, times that average annual leak rate, 25%, with a typical refrigerant that you would find today, the global warming potential of that refrigerant being about 3,900, times the number of supermarkets or grocery stores in the US, we get to a staggering figure of about 65 million tons of CO2 equivalent on an annual basis. Again, this is just the emissions coming from refrigerant leaks. If we want to take into account the total equivalent warming impact that supermarkets have in general, we'd also have to look at the indirect greenhouse gas emissions, or the energy use. And here, this is just to point out that supermarkets are have a very high carbon footprint in general. So not only are we seeing this carbon footprint come from the direct greenhouse gas emissions associated with refrigerant leaks, they also use a large amount of energy here, estimated at about 35 million metric tons of CO2e, and that's a very conservative estimate. So in general, this is supermarkets are a building sector that just represent a large amount of carbon footprint, and therefore a great amount or great potential for reduction. So HFC refrigerants are regulated at a global, federal, and in some places state level. And you can begin to, when you look at the environmental impact, you can begin to see why. Now, this isn't the first time that supermarket refrigerants have been regulated, and that refrigerants in general have been regulated. So if we look at the top timeline here on an international basis, all of this really started with what was previously used before HFCs, which were ozone depleting substances and refrigerants known as CFCs or HCFCs. And these were effectively phased out or phased down by a successful international treaty, the Montreal Protocol, that was ratified in 1987 and has been on a phase down schedule. And like I said, a very successful, the most successful international treaty. What replaced those ozone depleting substances were HFCs by and large. And so in effect, we traded one environmental disaster for another, and now needing to replace those HFCs because of their high global warming potential. And that's where we see the Kigali Amendment, which was an amendment made to the Montreal Protocol. So using that same framework and with the goal of phasing down HFCs to 85% reduction by 2036. This is for developed countries. The Kigali Amendment was introduced in 2016. Now, over 197 countries have ratified Kigali, and as I'll get to later, many countries around the world are well within, are well down the line with their phase out schedule. However, that's not the case in the United States, and we have yet to ratify this amendment. And I'll get to the impacts of that as well, but you can see the bottom timeline here shows the timeline for the United States in terms of the mechanism that was introduced to phase down the ozone depleting substances, Title VI of the Clean Air Act, and the EPA's SNAP program, the Significant New Alternatives program, and the rulemaking that subsequently reduced those gases and those refrigerants. Some of that has been put on hold and had a kind of start, stop, start again thing. And so in 2017, we saw a lawsuit come in and actually put those SNAP rules on hold. In 2019, we started to see the rise of state action. And so you may be located in a state where there are current HFC regulations either passed or in development, and you can get more information on that on our website. And then just recently, a lawsuit brought forward, a counter lawsuit brought forward by NRDC has now reinstated or partially reinstated those SNAP rules and moving again along with the phase down. But the US has had a rocky history with this phase down of HFCs and has been really inconsistent about the policies, and as a result, what we're seeing right now is really more like a patchwork of various regulations that differ state to state. How this whole thing plays out, or how it really comes down the line for supermarkets, how it plays out for a supermarket, really represents a series of painful and expensive phase outs of gases. So starting with the Montreal Protocol and the phase out of CFCs and HCFCs, each of these steps downward represent a lowering in the environmental impact of those refrigerants, but it also represents an enormous cost burden associated with the replacement of the gas, and as we'll see later on, the equipment that's associated with that phase down. So what some grocers have started to ask themselves is, instead of just doing these step-by-step incremental phase downs, why don't we jump ahead to the future-proof solution? And this is where we see natural refrigerants come into play. So again, if we're going to compare various commonly used refrigerants in the supermarket industry by their global warming potential, on the very right-hand side, you'll see those very high global warming potential HFCs that are commonly used today. So, almost 4,000 GWP. There's some middle ground GWP, that step phase that I was talking about, where you can change out the gas in the existing system, maybe make a few tweaks to the components of those systems, but you're still keeping the same system in place. And then when you get to the ultra low GWP natural refrigerants here, ammonia is a 0, CO2 is a 1, propane is a 3. This is a huge reduction in global warming potential pound for pound compared to what exists today. But natural refrigerants do require a system change out. So they are not what we call drop-in or able to just change out the gas and retrofit it and move on. You actually have to replace the entire system or piece of equipment. I'll get to more of that in a little bit. So as I mentioned, this is why natural refrigerants are known as the future-proof solution. The ones that we deal with most commonly when we're talking about supermarket refrigeration are going to be ammonia, CO2, and in the hydrocarbons family, we're going to be talking about propane. And so the characteristics of these refrigerants, they are naturally occurring, they cannot be patented, and they have a negligible impact on the climate. And as you can see from this graph on the right, it's really going back to where we started with refrigerants, or natural refrigerants. So the very first vapor compressor system ever built in 1934 used natural refrigerants. We moved on to from natural refrigerants because of some of their less desirable qualities. So ammonia is toxic, propane is flammable, CO2 operates at higher pressures. These were some of the reasons why synthetic refrigerants were first introduced. They didn't have these undesirable qualities. However, the safety factors of our systems and the regulations and codes and standards that guide them have improved significantly, and those undesirable qualities are no longer a problem in today's system. So as you can see, we've kind of come full circle around with the regulations guiding us back ultimately to natural refrigerants. Some of the benefits of natural refrigerants, so reduced emissions, obviously a significant reduction if we remember that comparison of the 4,000 GWP per pound compared to a 1 or a 0 of natural refrigerants, and that can have a very large impact on the overall carbon footprint or reduction of carbon footprint, especially over the lifetime of the equipment if we consider again that these systems are leaky. An overall improved TWE, so the total equivalent warming impact, and this is tied to performance or energy cost, and there is a potential for improved performance, energy efficiency, and cost savings associated with that, and the integration of new innovative technologies that are entering the market now that can further those benefits. And of course, regulatory compliance, so natural refrigerants are exempt from, for example, the EPA's Section 608 and represent a much reduced regulatory reporting burden for many supermarkets. If we look at the global adoption of natural refrigerants and kind of zoom out here from the United States, you can begin to see how far behind we are. If we just take a look at the installations of CO2 transcritical systems and we compare the US with Europe, you can see over the last 2 years, Europe has seen a significant growth in new installations, over 10,000 new installations, while in the US, we've only seen 180 new installations in that same time period, and a very different, much lower number of total installations in comparison. And so we have to ask ourselves, well, what is driving this slower adoption? And when we look across the barriers to natural refrigerants within the United States, there's really kind of two themes that we'll see emerging that are then connected to this problem that's preventing the economies of scale from really taking off and helping those adoption numbers increase. So we see that our regulatory mechanisms have been halted. I spoke about this in the fact that the Kigali Amendment has not been ratified. We have this kind of start-stop with the federal regulations being vacated and then reinstated. Overall, we have an administration that does not support moving forward on this initiative, and the U.S. has even withdrawn from important climate agreements, such as the Paris Climate Agreement that calls specifically for the phase out of HFCs in order to meet that less than 2 degree or 1.5 degree global warming rise. And coupled with that, we see a lack of incentives. And here I'm not just talking about a straight, rebate or money for upfront costs, even though that is a very big part of it. There's no tax incentives, tax credits, strategies that have been used by other countries to help with those economic incentives. And here in the U.S., the grocer must really bear the entire financial burden of paying for these new systems. And so in many cases, it's just not economically feasible for them to move to natural refrigerants. So, as a result, we're seeing incredibly low adoption rates, less than 1% of the US market in the United States, whereas in Europe, they're seeing, tremendous growth, greater than 15% adoption rates. We see that these high costs continue to prevail, and that we see that US technology is really lagging far behind the rest of the world. So really, if we move to the diagram on the right, we can see high upfront costs, driving also a lack of workforce training, a lack of data, and therefore driving that low demand or that low volume, which in turn only drives further high upfront costs. So it's this negative reinforcing cycle that we're seeing here right now. Some of the initiatives that NASRC is working on to reverse this cycle or create a virtuous enforcement cycle here. So starting with the reduction of first costs, here we see an opportunity for incentives to help reduce those first costs. We're in the process of developing new financial mechanisms, and a great example is a pilot program that we've introduced just this summer, the Aggregated Incentives Program that's being launched here in California. To address workforce training, we're working to develop training resources, including resources that can be used for the workforce that's just entering the service industry, or experienced workforce development who want to further their understanding of these new systems. We are promoting and organizing hands-on training events and providing opportunities for networking for those trained service contractors to get connected with retailers and grocers that are looking for those services. We are driving access to data through development of performance validation studies. We're working with a few research institutions and utility partners to drive these forward, and other initiatives to collect and share important return on investment data metrics with the industry, and of course highlight success stories through case studies. And then the last piece here that really needs to happen in order to see that increase in volume and demand, working with policymakers to inform their new regulations, especially on a state level. As I mentioned, that's what we're seeing a lot of activity right now, looking to update codes and standards where needed in order to allow those new technologies to enter the market, and help to develop best practices around these new systems and technologies. So my call to action today for you all, I hope this was an informative webinar. First and foremost, there's more to learn. We have a 1-minute video that I'd encourage you to watch and that we're promoting as part of World Refrigeration Day. Check out our naturally cool resources as well. A lot of great information there. You can engage with us either by joining membership if that's appropriate for your organization and you're working within this industry, or participation in our progress group activities and initiatives. Of course, we also welcome your support, whether you want to donate to us or connect with us on social media and share our posts. So with that, thank you very much for joining us, and please contact us if you do have any questions, info@nasrc.org.